Okay, good day learners. In this video we are going to start looking at the grade 12 analytical geometry. So for most of you this is a little bit new. Right, so let's jump in. I like the grade 12 analytical quite a lot actually. There's two things that's most important in this. Is the first thing is you have the general circle equation. Okay. That looks like this. This is on your formula sheet where the coordinates AB, if I write that as a set of coordinates AB, is the center of the circle. On your, that's a set of coordinates which will be the coordinates of, sorry for the ugly sketch, it will be the coordinates of that center of the circle AB, and the r is the length of the radius. All right, so in the equation you have r squared, which means if there's standing x minus 2 squared plus y minus 3 squared is equal to 25, the radius is actually 5. If they're standing 10, the radius is actually square root of 10. Okay, so just be careful of that square. And same as with some of the other functions that you do in the topic functions, there's these negatives in the equation there that you should also just be mindful of. If the equation says there x minus 2 squared plus y minus 3 squared is equal to 25, the coordinates of the center is actually going to be at positive 2, positive 3, because you see the minus is in the formula, the a is just 2, the b is just 3. So just be careful, that sign there in your coordinates writing down is wrong. If that's a negative 2, the coordinate would be positive 2. If that was a plus 2 squared plus, say for instance, y minus 3 squared is 25, the coordinates of the center of this circle is going to be negative 2, positive 3, because plus 2 I can write as negative 2, and then the negative from the formula is there, and then the a is actually negative 2, you see. So if there's a plus, the coordinate is negative 2. If there's a minus, the coordinate is positive. So just be mindful of that. But this is the equation of the circle. And the first important thing that they ask quite a lot in grade 12 we'll come to now. I think I'm soon going to explain them through examples. Let's just first familiarize ourselves with this just a little bit more. So easy examples, this is not what you're going to get in a test, but just to familiarize ourselves with the equation of a circle at any center. You'll see in most textbooks they first start with a circle centered at the origin. It's the same equation as this one. The center point there, AB, is just 0, 0. So that will just make this then x squared plus y squared if the a and the b is both 0. So I mean this also works for that. You just have a center at the origin would just be 0, 0. So I'm not really going to go through that now. I think the crucial thing is this. But let's just quickly look at this equation. So the first question here says, determine the equation of the circle with the center at 2, 3 and the radius of 7 units. Okay, so this is from the answer series, page 1.34. Circles at any center that I'm doing the questions from. If you are wondering, the answer series is a great book to work with. So question 21.1 wants to know a circle with the center at 2, 3 and the radius of 7 units. Write down the equation or determine the equation. Now this is not very difficult to determine, it's just to familiarize ourselves, as I said, with the formula. So the formula is x minus 2 squared plus y minus 3 squared is equal to 7 squared. So you see the coordinates of the center of the circle goes in the place of A and B. The radius goes in there, and I would rather write this actually as 49 and not 7 squared, but this you can leave. The x minus 2 squared plus y minus 3 squared. You don't need to multiply out that bracket. You can leave it like that. 49. Okay. Question 21.2 says, same question, the center of the circle at minus 1, 4, and the radius of the circle at root 5 units. So write down the equation of a circle with a center at minus 1, 4 and the radius at 5. So that would be x plus 1. You see the sign should be different because of the minus in the formula. So x plus 1 squared plus y minus 4 squared is equal to radius squared, which is going to be 5. Just be careful. The radius squared comes in the formula. So whatever the radius is, the square is here. If you have to write down the value of the radius from here, you have to take the square root to get the radius. Okay, so the formula is r squared there. Okay, so that's just to familiarize ourselves with the question or with the equation. Let's start looking at, there's two main important things in analytical geometry that you need to know how to do. The first thing is they're not going to give it to you like this. This is too obvious and easy and straightforward. They're going to rather give it to you like this. So they say x squared minus 6x plus y squared plus 8y minus 11 is equal to 0. So they give you an equation here, and then they say convert the following general form of the equation of a circle to the standard form, and then write down the center and the radius of the circle. So the first thing you need to be able to do with analytical geometry and the circle formula is you must be able to write an equation that they give to you into this form. And to do that, this might look familiar from something you did in grade 11, completing of the square, but now there's two of these things, so you need to do completing of the square twice in the same question. Okay, so completing of the square, right, you might have a different method than mine. What I do to complete the square, I'm going to first just do it on these two and then do the same thing on these two, so you'll be able to pick up what I do. I'm just going to spread them out quickly. X squared minus 6x plus y squared plus 8y is equal to, and I'm soon going to jump the 11 over. So the first thing I did is I just made space for completing the square. So there I have these two, then I have those two, and then the 11 I jumped over. Okay. Now you might have a different method if you're fine with that and you know how that works and you don't want to learn a new method or another method, that's fine. I think my method is easy and fast, but you're more than welcome to do whatever you do. Okay, so what I do is to complete the square, you basically want to add something here to the trinomial. You see this is a trinomial with something missing. Completing of the square literally means I want to complete this trinomial so that it factorizes into a perfect square, right? And to do that, I do two steps. You take this b value and into the square below, I'm going to work into the next step and then come back to this step. Into this step below, I'm going to take half of the b value, which is then minus 3, and put that there. So I have x minus 3, and then I square this, and then that's plus 9. And then I come back to the previous step, and then I complete the square there to factorize into this one. So it's basically you take the b value, you half it, there it is, you square it into the step below. And when I square it here, you must just add this value both sides. You can't just add something here, it's changing. So you can add both sides, then it keeps the equation balanced, right? So I half it, there it is, and square it, and then I add the square both sides. Okay, plus 9, and I'm going to do the same here. So I take the b value, I half it into the square below. I take this value, I square it, plus 16, and then I must add the 16 on both sides. So completing the square for me, I take the b value, half it into the square below, and square this value, and then that in the previous step, I add to both sides. Okay, and you can check, this one actually factorizes into that perfect square, this one actually factorizes into that perfect square. So I completed both these trinomials so that they are a perfect square. Completing the square is what this is called. Okay, and then 11 plus 9 plus 16, I think it's 36. Let me just double check. 11 plus 9 plus 16, so 36, yep. Okay, and then there you see this is now in the form x minus a squared plus y minus b squared is r squared. Can you see? X minus a squared plus y minus b squared is r squared. So from this, write down what is the center of the circle. The center of the circle is going to be 3, negative 4. As I said, just mind the signs. So if this is negative, that value in my center is positive. If this is positive, the value in my center is negative. And then the length of the radius in the equation, this is radius squared. 36 is radius squared. So the radius is going to be 6. Okay, and this is a very typical grade 12 question. Okay. Okay, let's look at the next question. Is the second thing. There's two main things that they ask quite a lot, which is your routine type questions. The first thing is they give you a non-standard equation that you must do this double completing of the square to be able to write the center and the radius. This is a very routine question. The second very routine question is that they ask you to calculate the equation of a tangent to the circle. Okay, that sounds like quite a mouthful. I'm just going to quickly explain to you in a sketch and then look at the mathematics. So, if I have a circle there, doesn't matter where it lies on my coordinate system, but if I have a circle, to determine the equation of the tangent there to the circle. Okay, two things are important. Firstly, the gradient, because this tangent, normally when I interrupt myself now, but let me just start from the beginning. Normally, when I determine the equation of a line, I have 2 points that I can use to calculate the gradient, and then substitute one of the points in to calculate the c value. Which a tangent by definition only has 1 point, and you will only have one set of coordinates that lies on this tangent. You don't have 2 points on the line. So to determine the equation of this line might seem tricky, but remember from Euclidean geometry that the radius and the tangent is always perpendicular to one another. The radius and the tangent is perpendicular to one another, and in Euclidean in analytical geometry, I know that perpendicular lines, the gradients multiply to be -1. So you are going to use this to calculate the gradient of that line. Okay, because you have 2 points of the radius, the center and then that point of tangency. So you can get the gradient of the radius. That's the first step you do. You get the gradient of the radius, right? Because you have 2 points and you can just use your normal gradient formula for that. Then you get the gradient of the tangent by using the fact that the two gradients or the two lines are perpendicular to one another. And then if you have this gradient, then you can work with the gradient and this point, substitute this point to get the equation of that line. Okay, everybody with me on the procedure? Right, make sure you follow this because it's not difficult, but it's quite a few little easy questions that you must be able to put together into one. So understand, I find this gradient, then from this gradient I find that gradient, and then the gradient I can substitute with this point into my normal line equation to get the equation of this line. Okay, so this is what the question looks like. It says, determine the equation of the tangent that touches the circle, 23.1, defined by x minus 1 squared plus y plus 2 squared equals 25 at the point 4, 2. Okay, so I have a circle defined by this equation. I want to calculate the equation of the tangent that touches the circle at the point 4, 2. Okay, that seems like a lot of information. This is my equation circle. This is my circle equation there, and then this is the point where the tangent touches the circle. That coordinate there is 4, 2. Doesn't really matter where this tangent is now lying around the circle, just to give you an idea. And they want me to calculate the equation of the tangent that touches the circle at 4, 2. So the equation of the tangent, right, of this circle. So that's the point 4, 2. The coordinates of the center, as you can see, is 1, -2. So that's 1, -2. And then the length of the radius, since this is 25, the length of the radius is 5, but that's not extremely relevant at this stage. I just want to calculate the equation of this line. So what I'm going to start with is to calculate the gradient of the radius. The gradient of the radius, difference in y, 2 minus -2, over difference in x, 4 minus 1, and that is 4 over 3. Okay, so then the gradient of the tangent times the gradient of the radius should be -1 because a tangent is perpendicular to a radius. The gradient of the radius I just calculated to be 4 over 3. And then from this, I get the gradient of the tangent is -3 over 4. If I take -1, divide by 4 over 3. Okay, so the gradient of the tangent is -3 over 2. That's the gradient of this tangent. And this tangent goes also through the point 4, 2. So I can use, I'm just going to use my normal y is equal to mx plus c equation to calculate the line equation of the tangent, and the tangent goes through the point 4, 2. So the x is 4, the y is 2, and from this I can calculate my c is 5 easily, and then that equation is -3 over 4x plus 5. Okay, let's look at another question like this just to make sure. Determine the equation of the tangent that touches the circle. It's the same question. Defined by x squared minus 2x plus y squared plus 4y equals 5 at the point -2, -1. Okay, so great. This is a combination of the two things that they ask most. So first we need to write this in standard form. Great. To write in standard form, I need to do my double completing of the square. I'm just going to space them out, x squared minus 2x, and give space for my constant term of that trinomial there, plus y squared plus 4y, give my space there, is equal to 5. So I'm going to start off here by taking half, which is -1, and then this I square and add both sides. Okay, then here the same thing, take half of the b value, square it, and add both sides. Okay, so that is then 5 plus 1 plus 4 is 10. So the coordinates of the center of the circle is 1, -2. Can you see that? The center of the circle is at 1, -2. This is not really relevant for this question, but just take note that the radius is root 10. It's square root of 10. Okay, but the center of the circle at 1, -2, and I have the point of tangency here as the tangent goes through the point -2, -1. So you don't need to draw the sketch every single time, but I think for some of us that thinks in pictures, it just makes it a little bit more tangible, the question. You can draw your tangent anywhere, it doesn't really matter. I want the equation of this tangent. So I know the point of tangency there is -2, -1, and the center of the circle is 1, -2. So I want to calculate that. That's my radius, and there's my tangent. I want to calculate the gradient of the radius first. That's going to be difference in y, -1 minus -2 over difference in x, -2 minus 1. And this is what, -1 over 3. I just want to make double sure. -1 minus -2 over -2, -1, -1/3. Okay, so then the gradient of the tangent, because I know a radius and a tangent is perpendicular to one another, the gradient of the tangent times the gradient of the radius should be -1, because I have perpendicular lines there. The gradient of the radius is -1/3, so the gradient of the tangent is 3. If I take -1 divided by -1/3, the gradient of the tangent is 3, and it goes through the point -2, -1. So I have an equation here with a gradient of 3 that goes through the point -2, -1. And I can just substitute this point here. X is -2, the y is -1, and then the c is 5. If I simplify this, 3 times -2 is -6. Add the 6 on the other side. -6 becomes +6. 6 minus 1, 5. Okay, c is 5. So y is equal to 3x plus 5 is the equation of my tangent. Okay, all right. I'm going to stop the video here. This is fairly your level 2 questions, routine questions with the analytical geometry. I'm going to do a separate video with a bit more challenging questions as well. But your routine questions that you should practice a lot of is really to get the equation in the circle equation in this form by doing the double completing of the square. And then that's the first thing. And the second thing is you should be able to determine the equation of a tangent to a circle by following the procedures as discussed. And then you're already set for most of the questions you can expect.